Hey guys, how you doing? It's Coach Scott's Chemistry again, Purple Wave Chemistry here with review part 2. Let's talk about these cooling or heating curves, temperature time graphs, whatever you want to call them. Okay, so let's think about something. I'm going to give you a scenario. Perfect. This is a cooling curve. Let's think about what's going on. Okay, let's see what phase I've got here. What's here? So I've got a temperature change. It's between 40 and 0. I know water is a liquid. It's a liquid between 40 and 0. I know that. Now, right at the start at 0, I've got a lot of liquid water present. So I've got liquid present. But it's going to start to turn into what? A solid. It's going to start to turn into a solid. When all the mass is turned from a liquid into a solid, it's rearranged their molecules and they're in that solid matrix. They can't move, they can't flow against each other. Okay? At the very end of that phase change, then it's going to do what? It's going to continue its journey down to where it's just slowly moving until you end up at minus 10. And now what's present here? Just ice. That's all a temperature time chart, a cooling curve, heating curve is. It's a roadmap with some known stops. We know with water, we have a boiling point at 100. It's also the vaporization point where the gas can turn into a liquid. We know that we have a boiling point for water at 0 degrees C. All right, to where when it melts, or melting point, fusion point, it either melts or it solidifies at 0 degrees C. So if there's every one of those phase changes, we've got to stop there and do something. All right, if it's in those temperature parts. So guys, just be cognizant of what's going on. These are not hard. Get some points here. Not hard at all. So anyway, let's do one more. Let's do a heating curve. Let's do a heating curve. Let me go up here. Where am I at? Oh, there we are. I had to find my pen. And we're going to do a heating curve. That means we're heating something up. All right. Should have left the final initial. Well, that doesn't want to erase. Let's see if I can do this. That got rid of it. All right. So let's see. I'm going to use blue. Initially, I've got some water at, I don't know, minus 15. And I'm going to bring it up to 30 degrees C. So my final temp is going to be 30 degrees C. So just like before, I'm at minus 15. I can't go straight up to 30 because I know at 0 I'm dealing with water is going to do something. Oh, I know it's going to melt. So at 0 it starts to melt till all of it's melted into a liquid water state. Then it's going to raise up to what? 30. And right now we're just going to hang out there because we're not adding any more heat to it or what have you. Say we're like in Mexico or something and it's really hot there. All right, and so that's almost room temperature. It's not, but let's say it is. So what did I've got right here? I've got a solid. Here I've got solid and liquid. I got solid and liquid. And here, after it starts to rise, I'm doing some temperature change. I've got a liquid present. Cool. I can live with that. There are several of them on our tests that are going to be like this. It's a roadmap of what's going on. Guys, you've got this, I promise you. So anyway, this is part 2. Coach Scott saying, Hullabaloo, connect, connect.